सो इस दफ़ा हम स्टार्ट करते हैं उसी पॉइंट से जहाँ पर हमने लास्ट टाइम अपने डिस्कशन को छोड़ा था कि हम रेफरेंसेस की बात कर रहे थे और ख़ास तौर पे मर्ज सॉर्ट की डिस्कशन के बाद हम लोगों ने ये अ, मतलब वी हैड दिस थॉट एक्सपेरिमेंट कि क्यों ना मर्ज सॉर्ट में 2 की बजाय 3 सब प्रॉब्लम्स बनाई जाएँ और फिर उनको मर्ज किया जाए, 3 वे मर्ज किया जाए। एंड यू कैन सी कि वी कैन डू 3 वे मर्ज इन O of n, making 3 arrays and just putting the data back together into a single sorted array. But the difference will be कि अब 3 रिकर्सिव कॉल्स होंगी और तीनों का जो साइज है 1/3 होगा। एंड वी वांट टू डू द एनालिसिस कि अगर हम एल्गोरिथम को ऐसे चेंज कर दें तो जो ये रेकरेंस बनेगी तो उससे ओवरऑल रनिंग टाइम पे क्या फ़र्क पड़ेगा और क्या किस तरह से ये कंपेयर होगा विद द यूजुअल मर्ज सॉर्ट। सो बेस केसेस भी मैंने यहाँ लिख दिए हैं कि बेस केसेस वही हैं, अगर 0 या 1 साइज़ की अरे है तो जस्ट अ कांस्टेंट टाइम। So again, we have this tree. So now this tree is not a binary tree because every tree has, like every node has 3 children. But and yes, one more thing, the height of this tree. So remember last time I said कि जो height है इस tree की वो depend कर रही थी कि यहाँ पर जो हमारा जो problem का जो size reduce हो रहा है, वो किस factor से reduce हो रहा है। अब जब 2 के factor से हो रहा था तो बार-बार division by 2 हो रही थी। तो हम कह सकते थे कि पहले लेवल पे साइज n की प्रॉब्लम्स हैं, दूसरे लेवल पे साइज n/2 की प्रॉब्लम्स हैं, तीसरे लेवल पे साइज n/4 की प्रॉब्लम्स हैं और 1 तक पहुँचते-पहुँचते हमें 2 से जो है वो log ऑफ n डिवीजन्स करने तक हम वहाँ पहुँचेंगे। लॉग लेकिन वहाँ पर जब मैं log n कह रहा था तो मैं असल में कह रहा था log ऑफ n बेस 2, राइट? अब अगर 3 से डिवीजन हो रही है डाटा की, तो जो हमें टोटल नंबर ऑफ डिवीजन्स चाहिए, दे आर actually log of n base 3. So when we say lg only, when we write lg only, like I have been writing before, then we implicitly mean that the base is 2. But now since the base is 3, I will just write log base 3 and then n. So actually, this is the total height in this case. इतने हैं number of levels. Log of n base 3. और इनको टोटल एक्यूमुलेट करने के लिए अब ज़ाहिर है वो टेक्नीक हमने अपनी सेम रखनी है कि हमने हर लेवल पे जो काम है उसको एक्यूमुलेट करना है और फिर हमने वर्टिकली सारा कुछ ऐड करना है। सो थिंग्स आर नॉट चेंजिंग मच इन दिस ट्री इन टर्म्स ऑफ वर्क डन पर लेवल। इफ यू लुक एट इट, फर्स्ट लेवल में अगेन जब लेवल n की कॉल हुई, सो वी आर टेकिंग सी एन वर्क। ओके, सो फर्स्ट लेवल में वही सी एन वर्क है और उसी तरह जैसे लास्ट टाइम हमने कहा था कि सेकंड लेवल में n/2 की 2 कॉल्स थी, सो cn/2 प्लस cn/2 इज n। अब 3 कॉल्स हैं लेकिन तीनों का साइज n/3 है, सो दिस इज cn/3, cn/3, cn/3 according to this recurrence, and the overall just comes out to be again cn, right? And then we have like 9 calls, each of size n/9, so this is like 9 multiplied by cn/9, and this gives you Cn again. Okay? And you go on, go on, go on. Last level, this is just n calls of size 1, that's just Cn. So not much is changing in terms of the series that we're going to get, because when I'm going to add these vertically, I get the same series, Cn plus Cn plus Cn. So actually, लेकिन जब मैं इसको T of n को write करूँगा, there will be one difference. Okay, what is that difference? तो फर्क ये है कि इस दफा जो नंबर ऑफ टर्म्स हैं वो log base 2n नहीं है बल्कि log base 3n है और हमारा जो फाइनल आंसर है वो ये है और अगर मैं इसको राइट आउट करता हूँ, दिस इज cn log of n base 3. नाउ so first, like earlier we had log of n base 2, just lgn, and now we have log of n base 3. If you look at just this much, you would think, well, this is a better algorithm because definitely log of n base 3 is a smaller number as compared to log of n base 2. I mean, let's just take any example. Let's say, let's think of the number 81. Okay. log of 81 base 3 is I think 4, right? क्योंकि 3 की जो fourth power है वो 81 है, 3 की third power 27 है, fourth power 81। लेकिन अगर मैं log of 81 to the base 2 करता हूँ, that's not 4, that's actually more than 6, right? It's between 6 and 7. So definitely it seems like log of 3 to the base n is smaller. It is smaller. But actually we can do some more sort of fine analysis of this and see कि how much smaller is it actually. So logs का एक formula होता है. I'm not going to prove it, but you can go back to your calculus book and you can confirm that I can relate two logs of different bases using a formula. Is a relationship. Actually, it's a very useful relationship if you want to convert logs from one base to another. So if you have log of n to the base a and you want to convert it into log of n to the base b, okay, you can use the following way to do it. So here is that relationship. Okay. Um, so if I want to convert um, a log of n base a to log of n base b, I should just take log of n base a and divide it by log of um, a base b. Actually, I think I just made a mistake. Let me correct that mistake. No, sorry, I made no mistake. It's fine. So yes, so log of a of the number you're taking the log of, and also log of a of the base, which was this older base. And this is a relationship. And actually, if you look at it, a की जो भी value हो, b की जो भी value हो, this thing is always a constant. Okay, so what this tells us is that any base of a log, okay, अगर मैं log n ले रहा हूँ, उसकी कोई भी base हो, they are just constant multiples of each other. Okay, so this already tells us that if a number is O of log n base b, then it is also O of log of n base a. So asymptotic complexity भी कोई फर्क नहीं पड़ रहा, first of all. Okay, so if this algorithm is n log n base 3, it is also O of n log n base 2. Yeah, just n log n. Okay, so but actually if we are still more careful and we see, okay, let's put these values in, let's take a to be 3 and b to be 2, and see if I want to go from log n base 3 to log n base 2, what is this number? So this number turns out to be 0.63. When it is multiplied, we get something like this. और इस इक्वेशन से हमें पता चलता है कि वेल अगर हम डिवाइड बाय 3 कर रहे हैं और जो लॉग की जो बेस है वो अब 3 थी, तो एक्चुअली ये जो मल्टीपल है, अगर मैं यहाँ पर अब मैंने log base 2 लिख दिया है, right? तो पहले हमारे पास जो था वो n log n था जिसमें log base 2 थी, अब उसका सिर्फ 0.63 पार्ट है. Okay, so we are multiplying by 0.63. So this should be like this should be like an improvement, right? It turns out that it's not really an improvement. And उसकी वजह ये है क्योंकि ये जो c है ना आपका, ये c डिसेप्टिव है. लास्ट टाइम जो c था वो भी कांस्टेंट था, और उस कांस्टेंट वो था तो कांस्टेंट और ये भी कांस्टेंट है, लेकिन this constant is going to be bigger than that constant, because remember in the last scenario, in the usual case, we always have just 2 recursive calls, and this time at every step we have 3 recursive calls. So what's happening is, if you know how calls happen, whenever you make a function call, you're using the stack, right? And you're doing your push cs and push ip with the knowledge of assembly, you know that. So we have an extra function call every time. Okay, and there are a lot of extra function calls. I will not go into the detail ki kitni hai. There are a lot of extra function calls. That's one. Second, think of the merge function. In the merge function, now I'm making 3 arrays using the new operator L, R, and U. And there are 3 new operator calls, and there are 3, there are 3 indices ij and k, ij and m. So everything, like there's a constant increase in each merge call. So in fact, when you look at all that At the end of the day, when you run this practically, you can determine that actually the C turns out to be, this fraction, C multiplied by this 0.63 is actually a bigger number than the C you had last time. Okay, so your usual merge sort में जो आपने C रखी थी, let's say that was C prime, that was C prime log n. Then this thing is actually, it turns out to be greater than C prime, meaning that आपको net loss हुआ है, net gain नहीं हुआ. Okay, so in fact, you can just look this entire analysis and really, I mean, this is a very, very important relationship that we'll keep in mind. It basically tells us that log की base change करने से कोई फायदा नहीं होने वाला, because एक log और दूसरे log की जो base है वो एक दूसरे का constant multiple है, और asymptotic level पे कोई फर्क नहीं पड़ने वाला. अगर आपने n log 3n लिखा था, यहाँ एक और constant multiply हो जाए, this is just going to become again n log n. Asymptotically तो आप अभी भी n log n है, लेकिन जो आपने extra calls की है, उन एक्स्ट्रा कॉल्स ने इस लॉग की बेस का जो छोटे होने का इफेक्ट है उसको जायल कर दिया, और ओवरऑल काम एक्चुअली आपका थोड़ा बहुत बढ़ जाएगा, कम नहीं होगा. ऑन टॉप ऑफ ऑल दैट, देयर इज वन एक्स्ट्रा थिंग. Dividing by 2 is always a more efficient procedure. So whenever there are these divide and conquer algorithms and you're dividing by 2, every divide by 2 is just a shift right. It's just an SHR. Also, just a multiply by 2 is just this instruction SHL. And if you go back to assembly, you will know that these are some of the fastest instructions. They just take like a single clock cycle or something like that. So they are extremely fast. So again, this constant C prime, which was there in merge sort, is actually quite small, or smaller at least, as compared to this C here. Okay, so this factor of improvement really doesn't come through. Okay, it's overshadowed by this C, which is bigger than the C prime. So therefore, it's just a standard norm that if you want to divide something into subproblems and you do not have any other criteria, but you just want to divide, usually we will divide by 2, make it into 2 pieces and not more than that. So I hope you get a detailed answer for this. If you get any other, so इसमें एक और चीज भी है. Whenever you look at these running times, you will always see n log n. Okay, you will always see n lgn and not any other base. And the reason for that is the one that I explained to you here. This is the reason that any log base is actually a constant multiple of any other base. So we, for standard, we just use this LGN everywhere. अगर आप कहते हैं n log base 3n algorithm है, it's just n log n asymptotically. Okay. So this is where we're starting. And now in the next part, let's look at 2 more recurrences which are different. And let's learn something from that.